Week number 4, weekend update video. This is Professor Hassey. I'm going to start calling it weekend update because I can never stick to my Friday schedule, and I always have to do these on Saturday mornings. Friday has been a difficult day for me these last few weeks, so let's call it the weekend update. And this week, we're going to finish our discussion of capital budgeting and lead into our next case number 3, which will be posted Sunday evening, this coming Sunday, February 27th, and due on Sunday, March 6th. It will be preparing a capital budget analysis and doing a risk analysis for a company. Very similar to this template you see in week number 4 that we began in our course lecture, our class lecture on at the beginning of week 4. So this is your template to study that. Many of you have done this prior in other classes. If you have not, this is the template to use to make this as easy as possible to understand what the strategic decision-making process is here. And that's what we need to calculate that on, because you're going to be doing the number crunching in case 3. And then also next week, I'm posting your course assessment case, which will be doing more number crunching, but also interpreting and writing a paper on what you find out. So that's the process which we're headed to on this Saturday morning, February 26, 2002. Again, live and in color from Claremont, California. So again, we began this week talking about the cost of capital, and you're doing case number 2 this week and due tomorrow, Sunday, in that regard. Kind of a short and sweet little case, not too much, just to calculate the cost of capital and to interpret that and for your firm. This is part of the capital budgeting process where we determine an asset investment and determine the return off that capital investment and the risk associated with that return analysis. And as you can see in the example we're using this week, we determined that the weighted average cost of capital was 8.1% by looking at the capital structure of the company, 60-40, and looking at the risk in the market as far as debt and the risk in the market of equity, looking at the capital asset pricing model and the after-tax cost of debt, putting those together into a weighted situation based on the capital structure, 8.10%. Then we looked at the base analysis of that, where I walked through that and determined that this particular investment of $1 million is generating an adequate return in net present value of over $500,000, an interest return of 17%, a profitability index ratio of the discounted cash flow in relationship to the investment of 1.48 times, and a payback in a little bit under 5 years. This is the basic capital budget analysis. Well, we're going to follow along this, and I hope you took this file folder and where I gave you a blank version, and maybe you tried to do it on your own and see if you could have done this. If not, it might be something worth to do, because you'll be doing this exact same thing in case number 3 next week. Now I want to pick up and do a risk analysis. A risk analysis is basically, are these numbers, are these projections? Remember, this is a projection, what we think is going to happen, what we think our selling price and our costs are going to be, what we think the inflation rate is going to be, what we think our returns are going to be from this type of investment. Is this a reliable analysis? Well, that's why we go to the next level, and it's called a risk analysis, where we do a scenario and a sensitivity analysis of the numbers. Now, basically, the scenario analysis takes a look at changes in the output level of units being produced and sold. And the sensitivity analysis is taking a look at designated specific variables from your analysis and doing a plus and minus of, if those variables change, how will that affect the present value of the company. So I'm going to walk through that this weekend in our update video. And I'll talk more about this in my class lecture video also on Monday for week number 5. But I want to walk through it this weekend. First of all, the scenario analysis says, in our original base case analysis, we said we were going to produce 25,000 units a year. At 25,000 units a year, our marketing people, our salespeople say we can sell them at $20 a unit. And it's going to cost us $8 a unit in variable costs and $50,000 a year in fixed costs. At that price, this is what, at those prices, that's what we think is going to happen for 25,000 units. But what if we change our output level based on the economic conditions at the time? We go to maybe a strong scenario. Maybe we can sell 35,000 units a year instead of 25. Or what happens if we're in a pandemic or a weaker economy and we can only sell 12,500 units a year? And what we do in this analysis is we weight the probability of those events occurring. Now, what do you mean that? Well, if any of you are familiar with strategic analysis at corporations, a lot of it is data analysis and analytics, right? Where we determine the probability of certain events occurring. Now, we don't have to determine those probabilities here, they're given to us. So in the case of this particular capital budget analysis, the data analytic people could be the cost accountants, it could be a variety of different people within your organization. It could even be your CPA firm that provides this probability data analytics. I have a tough time saying that. And in this case, it says that 50% chance of us selling 25,000 units for the next 10 years of this particular product. There's a 50% probability of that happening. There's a 25% probability that we'll sell these in a condition of a strong economy, selling 35,000 units a year. And there's a 25% also probability that we'll be in a weak economy, selling only 12,500 units a year. So what we do is we determine the net present value at those different levels of output. We don't change anything else. The only change is the level of output. And then we weight those to the probability that we think those occurrences are going to happen. Well, in our original case study, here it is right here. In our original case, we predicted 25,000 units to have an NPV of 504,799. So let's put that in here, 504,799. If you weight that by the 50% chance of that occurring, that probability NPV is weighted at 252,400, 50% of the NPV. Now let's go back to our base analysis and change one number, the output number, because I have all this preset at a variety of different equations setting this up. So if I go in and just change the output now to a strong version of the economy, or what we can sell this product to 35,000 units, notice I'm changing that there, and I hit enter, my spreadsheet automatically changes to include the additional $10,000 a month sales if we happen to see that. We're saying, what would this look like? Well, it looks pretty good. If we can sell 35,000 units a month with everything else staying the same, we can make a net present value of $1,117,358. So let's put that into our weighted analysis. The NPV at 35,000 units a year selling, 117,358. And that'll be weighted by the probability of that happening, 25%. And there you go. Now let's go back and put in the weak scenario of a bad economy or a pandemic economy or a very competitive economy, 12,500 units, and put that into our base analysis. And this is the good thing where spreadsheets can help you. Spreadsheets can adapt to the changes in your variables because you set up the spreadsheet correctly. So let's put in 12,500 units here as an output level. And notice, woo, a lot different scenario. If we only sell 12,500 units, with all else being the same, we're going to lose $260,899 in net present value. Notice the internal rate of return drops to 2.5%. The payback, we have to recalculate that, so that doesn't do that automatically. But we're just concerned with the NPV, 260,899 negative, a loss. And let's put that in there. Minus 260,899. And that is weighted to the appropriate 25% of our probability of that happening. So what have we done here? We've taken a look at all the options of everything going according to plan, and there's a 50% probability of that, of 25,000 units a year. The probability of a 25% chance that we will sell 35,000 units a year, and the probability of 25% that we'll sell 12,500 units a year. And we weight all those NPVs and total them up, and we come to $466,559. Even though we might have a drop in sales or an increase in sales, according to the probability and the weighted average of that, we're still making $466,000 of that weighted NPV. In that scenario, it looks like we can take the extreme, so the likelihood of these happenings by the weight of the probability. Naturally, if it does shift to 12,005, we know we're going to lose money and we'll have to act accordingly. But the overall analysis of the weight of probability to the NPV says that we're still going to be making a pretty good return on our investment. That's the scenario analysis of the risk portion. So it's the risk of changing outputs is not that great. We still are looking like, based on the probabilities, we're going to make that number. The sensitivity analysis is taking a look at specific variables and how they change and how they change the NPV. With everything else, and we go back to our base analysis of 25,000 units a year. Let's put that back in there. Now let's change key variables in this analysis, just the variables, and see how the change of that individual variable, plus or minus a certain percentage, affects the net present value or the return of the analysis. So in other words, I've selected 3 variables to review. Selling price per unit, which in this case is $20 a unit in the original plan. Variable cost per unit, which is $8 per unit in our original plan. And a weighted average cost of capital of what we determined is 8.1% in our original plan. What if these variables change? They reduce by 15%, 10, 5, or go up by 5, 10, or 15%. How does that affect the net present value of our budget analysis? Just changing these variables and they're leaving everything else alone. And I've created a table where this will be shown, and this table will relate to a graph over here. You'll see this graph grow as we make our analysis. Now, in the real world, you have what is called SAP, or Oracle software, that corporations purchase that prepare or that provide this information to the corporations in these risk analysis, especially sensitivity. You buy a software package, it downloads your accounting data, and it automatically will spit this out. But in the case of our class, I want to walk through it individually and have you try to do this in case number 3 to see if you can master the number crunching. And then what does it tell us about the sensitivity risk of this particular investment? So let's start. We go back to our base analysis here. And again, the original plan was the selling price was $20 a unit. All right. Well, now let's change the selling price per unit and lower it by minus 15%. Let's sell it for less than a reduction of 15% in our selling price at $20 a unit. Notice I'm not going to change any other variables. I'm just going to change the selling price. So I go to the selling price, $20. I put in equals times 0.85. Mr. Hassey, I thought it was 15% reduction. It is. 100% minus 15% is 85%. So we're going to take 80.85 of $20. And notice I have all this all set up in my spreadsheet. So when I change that and hit enter, it automatically adjusts the revenues for this project. Then notice what happens. If I reduce my selling price to $17 a unit, which is a 15% reduction, my NPV now is only $123,418. So I put that into my little table here I'm creating, $123,418. Put that in there, $123,418. That's the net present value of a 15% reduction in the selling price. What would be the NPV if I reduce selling price by 10%? Well, let's just go back to our variable of selling price and put that as $20 times 0.9, which is a 10% reduction in sales. We're now going to make $250,545 in net present value. $250,545. $250,545. Oh, and notice all of a sudden now you see my chart beginning to take place. I'm now going to chart this line of this sensitivity variable, selling price per unit. A 5% reduction in selling price. Let's go back to our spreadsheet. And that would be $20 times 0.95, which is a 5% reduction in selling price. And our NPV goes to $377,672. $377,672. $377,672. Naturally, a zero change in the selling price would be the same NPV of our original analysis, which is $504,799. And as you can see, my chart is changing. Now let's increase our selling price. Increase it by 5%. So we go back to our spreadsheet here. $20 times 1.05. That's a 5% increase. 100% plus 5% is 1.05. So we multiply that times our $20 selling price per unit. We increase our selling price, we probably will start making more money. And we do. $631,926. We're now selling our product at $21 a unit instead of $20. $631,926. And notice we keep on trucking. Let's put in a 10% increase in the selling price. $20 times 1.1. 10% increase. More profit, $759,054. This is when you have your spreadsheet set up correctly, and you can do all this analysis in addition to your base analysis of your original expectations. You can adjust it for the various risk analysis that you're doing. $759,054. And notice how our line is getting almost complete. And then finally, a 15% increase in our selling price, $20 times 1.15, and $886,181. 886, what was it again? 181. 886. And there we go. And notice I know I've done this correctly, because notice the line is exactly straight. There's no bumps, no blips. It's exactly straight. At 15% reduction in sales price, I'm only making $123,418. At 15% increase in selling price, I'm making just a little bit under $900,000 NPV. But since I'm doing it at increments of 5%, it's a nice straight line all the way. And that's graphing the NPV of different selling prices. Now, why would you do this? Well, because maybe in a bad market, if we want to sell 25,000 units a year, we'll have to sell it at a lower price. All right. If we want to maintain the volume of 25,000 units a year, maybe we have to sell our product at $17 per unit instead of $20. And if we do decide to do that, we're still making money, but not as much. And on the other side of the coin, what happens if our product is very efficient and there's a high demand for our product, and we're only based on manufacturing and supply chain issues, we only can produce 25,000 units, but we'll increase the selling price because there's a high demand for our product. We can sell it and make even more money in that market because of the demand for our product in the market. It gives us variances. And the total variances, top to bottom, are 776,000, 762, 763, from 15% reduction to 15% increase in selling price. That's the range. And the range dictates the steepness of this curve. The higher the range, the greater the slope. All right, so now let's go back to our base analysis and put everything back to normal. Let's take our $20 and put it back to $20. And then we're back to $504,799. We're back to where we started out. Now we're going to take the variable cost per unit of $8 and change that by our percentage of deviations and see what the NPV will be if we change our variable cost rate, changes in our expenses. And let's see what that does to the NPV, leaving the selling price at $20 a unit. So $8 is our variable cost. Take that times a 15% reduction times 0.85. The same procedure as we did before. $8 times a 15% reduction is 85% of $8. Notice we're going to be making more money because our variable costs have dropped to $680. Our NPV is $656,471 under that risk change. $656,471. All right. Now let's drop our variable cost rate by 10%. So $8 times 0.9. We're making $605,914. And now our line starts going the other way. This is an expense, so the line goes the other way, and we begin to see that in our chart. A 5% reduction in variable cost. Notice I don't change any other variables. It's just the variable cost rate that changes here. So that's $8 times 0.95. 555,357. 555,357. And our original one is zero change will be still 504,799. And see our line, oh, and there it meshes right at the middle of the revenue line. So you know you're doing this correctly. Now we're going to do a 5% increase in the variable cost. So our costs now are going to go up. So now we expect to make less NPV. So let's take $8 times 1.05, 5% increase. There we go. 454,242. 454,242. Now there are macros and programs that you can just do this automatically, boom, and it creates it. But for this class, I wanted to walk through it one by one so you see how this all works, so you can get a feel of how these changes occur. A 10% increase in the selling price variable cost rate of $8, $8 times 1.1. 403,685. And our line continues to be straight as an arrow. And finally, a 15% increase, $8 times 1.15, 353,127. And there we go. Notice it's still notice how the slope of the line is not as severe as the selling price, and that's related to the range. The range is a lot lower. from top to bottom here. Thus, the slope is a lot flatter. And it's showing us that, yes, if variable costs do change, we will have a change in NPV, but not as dramatic, naturally, as if we have a change in the selling price. Changing selling prices affect your profitability a lot more than specific segments of your expenses. And it's shown in this little analysis. Now the last one, weighted average cost of capital, which is a little bit different to calculate. We go back to our base analysis and put everything back to normal. Back to $8, 504,799. And now remember, we have to change our weighted average cost of capital. That would affect the discounted cash flow. Remember, weighted average cost of capital is part of the discounted cash flow, taking 8.1% and using that as our discount rate for our net cash flows over the length of the time. So now we're going to change that percentage in that formula. So remember, the risk analysis shows 15% changes in WACC. So if our cost of money is reduced by 15%, we'll go to this, back to our equation, or back to our variable, weighted average cost of capital, 8.1% times 0.85, a 15% reduction in the percentage rate. We get 6.89%. Now we have to go to our discount cash flow equation right here. See, here's the equation. There's the 8.1% discount rate in that calculation. So we now got to change that to 6.89%. Changing that cost of capital gives us money is cheaper. We're going to make more money. 600,855 NPV. Notice all the other variables have not changed. We're just changing the cost of money. 600,855. And there we go. Now, a 10% reduction in our cost of capital, 8.1% times 0.90. 7.29% is now our weighted average cost of capital under this sensitivity analysis. So we put in 7.29 in our formula, 729, and we make 568,147 in net present value. 568,147. And our line begins to take shape again. A 5% reduction in our WACC, 0.95 times 8.1%. 7.7% is now our adjusted WACC number. Put that into our equation. 7.7. 535, 611. 535, 611. And naturally, with no change in WACC, we still make 504,799. And notice we're doing it right. Everything is meeting at the area where 504,799 for all three of those variables. Our line is nice and straight. We're doing this correctly. Now let's increase our cost of money. Increased our cost of money by 5%. So 8.1% times 1.05. 5% increase in cost. That's 8.51. Put that into our equation. 851. Naturally, we'll lose less money now. Our money is more expensive. 474, 138. 474, 138 is our NPV there. A 10% reduction in our cost of capital, or 10% increase in our cost of capital, 1.1 times 8.1, 8.91%. Put that into our discounted cash flow formula, 891, 445, 090. I know this is kind of redundant, but it's good to walk through this. Notice our line is nice and straight. And then finally, a 15% increase in our cost of capital, 1.15, 9.32. Adjust our formula. 932, 416, 171 is our NPV, 416, 171. And there we go. As soon as we're done with that, let's make sure we put our numbers back to where they were before, so we don't avoid any confusion. Now we're back to our original area. We'll save our spreadsheet, go back to the risk analysis. And what does this tell us? Well, it tells us a variety of things. First of all, it tells us that we've done these calculations correctly because all the lines are straight. Let's see if let me show you. What happens if I transpose and do some wrong numbers here? Let's say instead of 759.04054, I put in 579. See what happens to my line there? It goes wacky. I transposed the number, I typed it in wrong, and I know I did something wrong because all of a sudden my line looks like it had a couple of beers. So that tells me I did something wrong. So what did I do? Oh, yes, I transposed those wrong. 759.054, put that back in. There it is. I did okay. That happens sometimes. You just keystroke in a wrong number, but you'll notice you did something wrong when your line is not straight. That's one thing. Now, what does this tell us also in regards to strategic decision making? It tells us, it gives us an idea. Naturally, the selling price is going to have the most influence on our range here because it's what we're selling it for. But it tells us under different circumstances, if we want to sell our product at a different price, what type of profitability. Also under variable costs, what happens if we sign a new labor contract, a new union contract, or what happens if the pandemic causes a shortage and we have to pay more for our supplies or costs. We can take a look at how those changes affect profitability in that sector. And what happens if the cost of money changes? What happens if our credit changes? What happens if inflation starts happening and that changes our cost of capital? How does that affect our profitability? So it gives us a variety of different views of different changes in the environment around us and how that affects the profitability of this base case analysis of an investment of a $1 million asset over 10 years. We'll talk more in week 5 about these strategic decisions and how to interpret this. But in week 4 now, we've now looked at how we crunch these numbers in this template that's in your week 4 file folder in Blackboard. This is key. This is going to help you do case number 3, which is posted Sunday evening. That's our weekend update video, capital budget, risk analysis. We'll see you all on Monday in our week 5 lecture video and a discussion of case number 3. Before that, though, please finish up your case number 2 this week and post it by midnight on Sunday. Thanks, everybody. Have a great weekend. Be well. Adios.